Welcome to this video where we'll discuss converting binary numbers to decimal numbers. I'm going to show you why this process works using decimal numbers first, and then I'll show you the shortest and fastest way to convert binary numbers to decimal numbers. So we have here a decimal number, 1526. We can write that same decimal number as a combination of 1000 plus 500 and 20 and 6. So of course, you add that all up, you get 1,526. So let's go ahead and put plus marks there. And I'm going to just kind of rewrite this. This is 1 times 10, or 1,000, plus 5 times 100, plus 2 times 10, plus 6. So all I did is take off the zeros up here and put them as 1,110 and then of course 6. Now we can change this a little bit further. Instead of writing 1,000, we can just write 10 to the third, and 10 to the third is 1,000. 10 squared is 100. 10 to the power of 1 is just 10. And 10 to the power of 0 is actually 1. So we get the same number here. And then all we have to do is add these together and we get our number 1,526. Now, to convert binary numbers to decimal, we're going to do the same thing. The only thing is our 10 here that we use for decimal numbers will be replaced with a 2. Now over here we have the least significant digit, that's the digit furthest to the right, and if you notice that was multiplied by 10 to the power of a 0. So now the least significant bit, which is the bit furthest to the right, will be multiplied by 2 to the power of 0. And then notice this is 10 to the power of 1, 10 to the power of 2, 10 to the power of 3. So the power goes up each time we move to the left on our digits. So when we move to the left on our bits using binary, we're going to increase the power of 2 that we use. So we can see over here 10 to the power of 0 on the furthest to the right. And using decimal numbers, using binary numbers, we have 2 to the power of 0. Now, all we have to do is figure out what these powers are equal to. So this 2 to the power of 0 is actually equal to 1. 2 to the power of 1 is equal to 2, then 4, then 8, then 16, and then 32. Now, if you notice, there's a pattern. Each time we move this way, we double the number. So 1 doubles to 2, 2 doubles to 4, 4 doubles to 8, 8 doubles to 16, 16 doubles to 32. So what would be the next one if we had another bit up here? Well, that would be 64. So now once we've done that, now all we need to do is do the multiplication and the addition. So the multiplication is easy because we're either going to multiply by 0 or 1. So if you notice, I took 10 to the power of 3 and I multiplied it by that number, so 1. And then 5 to the power of 2, I multiplied 10 squared by 5. So here I would need to multiply 2 to the power of 5 by 1, and 2 to the power of 4 by 0, 2 to the power of 3 by 1, and then by 1, by 0, and 1. Now, when we have our numbers written out up here, it's pretty easy. Anything multiplied by 0 is 0, and anything multiplied by 1 is itself. So all we have to do is pick out our ones, which is this one, that one, that one, and that one. All the rest of them, these are going to be 0 no matter what. So pick out the ones, find the number up above them, and add all those numbers together. So we have 32 plus 8 plus 4 plus 1. Now, just again, why did I skip this one? Well, that's because there's a 0 in this spot, so that's going to multiply out to 0. This is going to multiply out to 0. Then here we have 32 plus 8 plus 4 plus 1. So we just add those up and we get 45. So this number is, in binary, this number is 45 in decimal. So now let's just try another example. We'll try to convert this binary number to decimal. And so we'll start off by listing the powers of 2 up above each number. And then we can take our zeros and cross them out. So don't need 64, and we don't need 4. And then we just add up the rest of the numbers. So we have 128 plus 32 plus 16 plus 8 plus 2 plus 1. And so we can try to do this in our head or just grab a simple calculator and add them all up, and we get 187 as our final answer. So this number in binary is equal to 187 in decimal. Okay, now let's go the other way. Let's start off with a decimal number and convert it to binary. And we do this by dividing the number by 2. Now I'm going to kind of use a long division notation, but I'm going to go upside down, and you'll see it just kind of helps keep you organized. So we're going to take 45 and divide it by 2. Now 2 goes into 45 22 times, and 22 times 2 is 44, so there is a remainder of 1. So it's really 22.5, but we're going to keep it as whole numbers with remainders. All right, now let's divide 22 by 2. 22 divided by 2 is 11, and there's no remainder. 11 times 2 is 22, so there's no remainder. Now let's divide 11 by 2, and that is 5. 5 times 2 is 10, so there's a remainder of 1. Now the remainders are important because they're going to end up being our binary number. Now let's divide 5 by 2. 2 goes into 5 2 times, and there's a remainder of 1. 2 times 2 is 4, and so there's a remainder of 1. Now let's divide 2 by 2 again, and that is 1 time, and there's a remainder of 0. And finally, and this will always be our last step, the last step is always this division. You're always going to divide 1 by 2. Now 2 doesn't go into 1 any times, but there's a remainder of 1. So at the very end, you're always going to have a remainder of 1 no matter what. Now, when we go to write the binary number, and a lot of people miss this step, so make sure you pay attention. We want to write the number starting with the last one, working our way up to the first one. So the final binary number is 1, 0, 1, 1, 0, 1. And so here's the first number, then the second number, then the third number, fourth number, fifth number, and sixth number. So this should be 45 in binary. And we can check our answer by going back to our previous calculation. And sure enough, we get 1, 0, 1, 1, 0, 1. So we just kind of did it in reverse. And that's why I chose 45, because I already knew what the binary number was. So we can see that just by reversing, going back to binary, we ended up with the same number. So that's a good way to check your answers. If you ever make small mistakes or something and you end up losing points on math tests or something, it's a good way to find some way to check your answer. So this is how we could check our answer. And if we want to check our answer again, we can just simply convert this binary number back into decimal. 4, 8, 16, 32. Cross out these numbers, and so we get 32 plus 8 plus 4 plus 1, which is equal to 45. Now, just some other things that you can do to check your answer is, first of all odd numbers will have a 1 in the least significant position. So if you started off with an odd number and you end up with a 0 in the least significant position, then you know that you got your wrong answer. And again, how you might mess it up is just with your math over here. But what a lot of people do is they end up writing the number this way. And in this case, it doesn't matter. It just happens to read the same way frontwards as backwards. So it just happens to be a palindrome, but not all numbers are going to be palindromes. So you really do need to make sure you read your number up this way. And the way that I remember it is the most significant bit always should be a 1, or else, you wouldn't start it off with zeros in front of it usually. Although later on in class, we're actually going to do that quite a bit. But usually in your right numbers, you don't pad them up with zeros in the front. So the most significant bit has to be a 1. And remember that last step that you're always going to do is going to lead to a 1 being in the most significant spot. Okay, now let's talk about hex. Now, the reason why we use hex numbers is because, and you can try this on your own, staring at ones and zeros gets very tedious, it's very error prone. So what mathematicians and later scientists did is they decided instead of printing out the numbers in binary, they would print them out in hex. Now, why not print them out in decimal? Well, of course, we print it out in decimal most of the time, but if you ever get into the nitty gritty and need to deal with the binary, looking at it in hex is a lot easier. And it's pretty trivial to convert numbers from hex to binary and back to hex. So the conversion process is really easy. So what is hex? Hex means that we have 16 different symbols. So when we start counting above the number 9, instead of using 10 as our next number, we use A, and then B, and then C, and then D, and then E, and then F. So those are hex numbers. Now, just so you know, we still do the same thing that we do in decimal and binary. When we reach F and run out of symbols, then we move to the next number. So when we have 1, 0 in hex, then that really converts to the number 16 in binary. So this is our hex, and 16 in decimal, not binary. So here's our decimal number. Okay, so those are hex numbers, and to convert from hex to binary and binary back to hex, all you have to do is come up with write down all of your hex symbols, and then start counting in binary. So we got 0, 0, 0, 0, 0, 0, 0, 1, and I'll do the rest of these really quickly. Okay, now that I've done this, now we have a conversion chart. So whenever we see 4 zeros in binary, we just replace it with a 0 in hex. And whenever we see a 0 in hex, we replace it with 4 zeros in binary. So let's do a couple of examples. So I have a binary number here, and as you look at it, you can tell, well, it's kind of hard to tell what it is. Of course, you can convert it to decimal, but let's go ahead and convert this binary number to hex. So we start off with, now you usually want to start at the least significant part, or at least pair them up in groups of 4. So these 4, these 4, these 4, and these 4. And each group of 4 will convert to 1 hex character. So let's start with this one down here, and that is this one, so that's the number 1. And now let's convert these 4, this group of 4, and let's look for 0, 1, 0, 1, and that's right here, so that's the number 5. So we'll go ahead and write down 5. And then we got the next 4, 0, 0, 1, 1, and that's 3. So now we can put the number 3 right here. And then we have the next number, 1, 0, 0, 1. And if you notice, that's the number or the letter B. So we'll put a B there. All right, so we have B351. Now, just to note, how do we know, is this a decimal number? Is this just B351, like a decimal? How do we know this number is a hex number? So the sign that we do is we put a 0 and a lowercase x in front of the number. So whenever you see the 0x, that's just a sign saying the number that follows is a hex number. So whenever you see the 0x, that again, this is not part of the number, but it just tells you that the numbers and letters that follow happen to be a hex number. And by the way, for binary, sometimes you'll see a little lowercase b at the end for binary numbers. So those are ways that you can tell what the number is. If the number doesn't have anything, you just assume it's decimal. If it has a little b behind it, then you assume that it's a binary number. Of course, if you just see zeros and ones, you can maybe kind of assume, that's going to be a binary number. But now let's go ahead and practice converting this back to binary. So it's just the same process in reverse. We start with this number right here. We go to our lookup chart, find the number 1, and we replace it with a 0001. Okay, and then the 5 is a 0101. The 3 is 0011. And the B is 1011. So see how it's super fast to convert from binary to hex and hex to binary. And if you have to deal with binary numbers a lot, you end up kind of memorizing this chart right here. And that's not something we'll necessarily do in this class, but you'll end up memorizing this chart. And then you can just know, and in their heads, when they see B, they automatically see these binary numbers behind it.